Hello and welcome. In this video, we're going to learn how to measure the creatinine of a sample, and we are going to use two different types of reagents. So I'm going to show you how they are used, even though their principle and the way we do them is the same. So we're going to use MedSource, this reagent. If you're in Ghana, this is one of the commonest one you will be using. So we're going to learn how to use this reagent MedSource to measure, and then I have a second one. I'm also going to show you how to use it. This was manufactured by Inolitech. Yeah, I hope I got that right. It's also a creatinine reagent. I'm going to show you how to use them. You store this at RT, and so that's about the reagent. So a quick one about creatinine. What's creatinine? Creatinine is a metabolic waste product of creatine phosphate, and creatine phosphate is the energy source in most skeletal muscles. So most skeletal muscles use creatine phosphate as their energy source for their activity. After that, creatine will be produced as a waste product, and the body doesn't have any more use of that, so it has to excrete the creatinine from the body, of course through the kidney. And so um, we measure creatinine mainly to assess your renal function, because after creatinine uh, has been produced from creatine phosphate, it has to be excreted out of the body, and then um, it's done through the kidneys. And so if the kidneys are working properly as they should, then they should be able to eliminate most of the creatinine in your blood. Okay. um as I already said, we're going to use two different reagents, and they are basically the same. Okay, so this is a semi-auto analyzer, and we are going to use this. I'm going to show you how we do it. So this is the test button, then results, maintenance, power management, reagent setup. We are mainly going to use these two, the test and then the reagent setup. Okay, so I go to my test site, and then this is where I've programmed creatinine. That's the create. So I select that, and then this is how the interface will show. So firstly, it will ask me to aspirate a water blank, and I have my DI water here, so I'm going to aspirate that. Okay, but before all this, you need to program the machine, and I've already programmed it, but I'm going to take you through how it's done so that you'll be able to do it. So let's return back again, and then you go to the reagent setup. This is where you set up any parameter that you want to measure. So I'll go to the create and then show you how we set it up with a different parameter. So first is the test name. You put creatinine there. Then the method is a fixed time. So creatinine is a fixed time, or if you want 2-point kinetics. Good. And you get all this information from the reagent insert. So this is the reagent insert for the MedSource reagent, and then this is the system parameter. So all this information here has to be inputted into the machine. So let's go through quickly. So the reaction type is fixed time or 2-point kinetics. Then the reaction direction is increasing. It means that as we measure, our graph should actually go up. And so if the graph is not moving as is expected, then you have reason to repeat your labs again. Okay, so it's a very good guide to know whether the measurement that you took is okay. So you always make sure you look at the reaction direction. Then the wavelength, you take 520. If you don't have 520, you can use 500 to 546 nanometers. Then the temperature index should be 37. Then we use a water blank. Then the delay time is 30 seconds. With every 2-point kinetics. There's an initial reaction before the first measurement, and then the second measurement at 90 seconds. That's a fixed time. So that's why this particular reaction is called a fixed time or 2-point kinetic. Okay. And then the sample volume is 100 microliters, reagent volume is 1000 microliters, and then that's the standard concentration. Then the linearity is 25.0 milligram per deciliter. The unit is milligram per deciliter. We're going to use milligram per deciliter to program the machine, but when you're finished, we can convert that to micromole per liter. We have the conversion factor there that you can use. It's available online. Okay, so then the low normal is 0.6, and then the high normal is 1.5. okay. This reagent is an open source reagent, so if you read from here, it says this assay is suitable for a colorimeter, spectrometer, a semi, and then a fully auto analyzer. Okay, if you are using this to work on what do we call it, a semi-auto analyzer, this is how you go about it. Sorry, a colorimeter first. This is how you go about it. You prepare your reagent, that's your working reagent, and then you add 100 microliters of the sample to it, and then you wait for 30 seconds, and then you take your first reading, and after 90 seconds you take your second reading. That's for a colorimeter. But if you are using for a semi-auto analyzer, you program all this into the machine. So after you prepare your working reagent, add your specimen, 100 microliters of specimen. You don't wait for 30 seconds because you've programmed that into the machine. Okay, so that's the only difference between a a colorimeter and then a semi-auto analyzer. It does that waiting for you. Okay, so I hope you understand that. So that's the programming for the machine. I hope you can see that. Okay, so that's the wavelength 505. That's what was available. Then the incubation time, you make it 30. That will be our delay time. Then the testing time will be 90 seconds. And we made the aspiration 250. Then we are leaving the unit to be milligram per deciliter. Then these are reference in the low normal and then the high normal. Then our linearity is 25. Then the temperature, of course, is 37. If you come to the calibration site, and let me use a pen. We are leaving it to 1 point linear. We are using a water blank. Then the factor is 28.6. If you run your standard and everything, it will generate the factor for you. We've already done that, so we are not going through that again. Okay, so return, and then we go to the test and we show you how it's performed. Okay, so I have my reagent. So the principle here is very simple. So picric acid will react with creatinine in an alkaline medium to produce an orange-red color, and then the intensity of the color is proportional to the amount of creatinine in the substance. So this is my reagent, and then if you open in there, you have a picric acid reagent, you have an alkaline buffer, and then your standard. We are not going to use the standard because we've done the calibration already. So this is the alkaline reagent, and then this is the picric acid. Okay, so we will pipette. We'll create a working reagent. To do the working reagent, it says that mix 1 volume of the picric acid reagent with 1 volume of the alkaline reagent as per required. Then the working reagent is stable for 15 days when stored in a dark room. So I'm going to use 500 microliters of each, and then put in my my epinephrine tube. Okay, so this is my micropipette. I'm going to set it to 500 microliters. So that is 500 microliters for you. I'm going to aspirate. So that is 500 microliters of the picric acid, and then it goes into my epinephrine tube. Then discard. Then I add another 500 of my alkaline buffer to it. So that's another 500. So you mix, and then okay, so you close and then you mix by shaking it. Okay, so our working reagent has been prepared. What we need is our sample, and then we start testing. Okay, so we have our sample here. I took it from the fridge, so allow it to cool down, and then we'll aspirate 100 microliters of that. So this is my micropipette for 100 microliters. So I'm going to transfer 100 microliters of the sample in there. But before that, you prepare the machine. So you go to your test, then you select the creatinine side, and then it tells you to aspirate the water. So you're going to aspirate your DI water. So I have it here, and then I go here and then I click aspirate. Okay, so you should have a tissue for cleaning after everything. Okay, so you can press yes and continue, but I feel that the primary offset is too high, so I want to repeat this thing again to have a more lower primary offset so that my measurements could be more accurate. Okay, okay, so I have primary offset of 11. I feel that okay, it will give me a very good measurement. So I go to yes, and then from here I can transfer 100 microliters of my sample into the working reagent. So that's it. I'm going to transfer. So that is 100 microliters of my sample, and I'm going to transfer it into the working reagent. Okay, and then you mix. Mind you, this is a semi-auto analyzer, so you don't wait. After mixing, you aspirate. So right from after mixing, then we aspirate. So okay, then you put it aside. That's all. And then you observe the graph. Very, very, very important. Observe the graph so that you can get a very good measurement. So if we were using a colorimeter, then we'll wait for 30 seconds before we take our first reading, and then wait for 90 seconds and then take our next reading. I hope you get it. But because this is a semi-auto analyzer, you don't have to wait. That programming has been done in the machine. So the first reading will be taken at 30 seconds. After 30 seconds, so all that waiting will be done by the machine, and then the second reading will be taken at 90 seconds. So that's why we call this particular method a 2-point kinetic. I hope it makes sense. Okay, so let's wait for it. So you wait for it to measure. So after this, I'm going to show you how we use the other reagent to also work to measure the creatinine. The instructions will be a little bit not so clear, but basically the way we program a 2-point kinetic is the same for most analytes that use a 2-point kinetic. So the way we program for this will most likely be the same thing for most reagents. Okay, so we are almost done. So it's done. Let's see our results. We had 0.6, so that's 0.6 milligram per deciliter. If you want your answer in micromole per liter, so we have 0. So to get its equivalent in micromole, you multiply by 88.4. That's the conversion factor. You can look it up online. 88.42. So that will be so 0.6 times 88.4, so that will be 53.05. so that's the creatinine of this person in micromole per liter. So you have it in this way. So that will be our final result. So when you are done, you wash, because the picric acid can actually color your flow cell. So you wash by aspirating liquid twice. Okay, so basically that's how creatinine is measured. Let me quickly show you how we also use the this reagent. It's also almost the same. It comes with the picric acid and alkaline buffer. So this is the creatinine reagent, which contains the picric. Okay, this is the alkaline reagent, that's number 2, and then it has the picric acid. So the instructions are almost the same, but sometimes the way they write it on the paper doesn't make it clear. So let me show you. So procedure, so it gives you the wavelength, and then the temperature, then the procedure. So working reagent, that should be 1000, and then you obtain it by mixing 1 volume of picric acid to 1 volume of the alkaline reagent, and then you add 100 microliters of your sample. So make sure and read at 30 seconds the absorbance of the standard. We are not going to do the standard. Then at 90 seconds. So it's basically the same. So it's the same for every 2-point kinetic. So that's about this one too. So we're not going to go through all because it's the same. So Kudus, that's about creatinine. If you have any questions, you can send them to me, and I'll answer as much as possible. Okay, thank you. Bye.